Chapter HCF and LCM for grade 6 and 7. Topic: Word problems of HCF and LCM part 2. Hello everyone. In my previous video, I told you that there are two types of word problems of HCF and LCM. First type of word problems I have explained in my previous video. In this video, I will cover the second type of word problems. In this sums too, students face the same problem that they are unable to understand whether we have to find HCF or LCM. So in this video, I will try to give you some keywords and how to understand the sum and decide whether we have to find HCF or LCM. So we will start with our first sum. Find the greatest number that divides 180, 225 and 315 completely. In this sum, the keywords are greatest number that divides. Not only greatest number, but greatest number that divides. That divides is the keyword over here. So here, the greatest number that divides means we have to find HCF. And the three numbers which are given to us are 180, 225 and 350. I am using a common division method. To solve this, you can use any method to find HCF or LCM. 3 can divide all these three numbers and we get 60, 75 and 105. These three numbers are again divisible by 3, so we get 30, 25 and 35. These three numbers are divisible by 5 and we get 6, 5 and 7. 6, 5 and 7 are not divisible by any common prime number. So the factors we got are 3, 3 and 5. So HCF will be 3 into 3 into 5. So we will write that HCF of 180, 225 and 315 is equals to 3 into 3 into 5 equals to 45. Then we will write a complete statement. Therefore, 45 is the greatest number that divides 180, 225 and 315 completely. Here the sum ends. You have to just write till here. This part is just for understanding. Now the first number, that is 180, when we divide it by 45, we get 4 as the quotient and 0 as the remainder. When we divide 225 by 45, we get 5 as the quotient and 0 as the remainder. And when we divide 315 by 45, the answer is 7 with 0 as the remainder. That means 45 can completely divide all these three numbers which we got and it was asked in the question. Next sum, find the smallest number which is exactly divided by 12, 18, 24 and 36. Here the keywords are smallest number which is divided by. Divided by is given. That means we have to find LCM. So here the given numbers are 12, 18, 24, 36. So the first statement we will write smallest number divided by. That means we have to find LCM, and LCM of 12, 18, 24, 36. So here the factors are 2, 2, 2, that is 3 times 2 and 2 times 3. So the LCM will be 2 into 2 into 2 into 3 into 3. That is equals to 72. So the next statement will be LCM of 12, 18, 24, 36 is equals to 2 into 2 into 2, that is 3 times 2 and 3 into 3, that is 2 times 3, that is equals to 72. Therefore, 72 is the smallest number exactly divided by 12, 18, 24 and 36. So this is the last part of the sum. Again, just to verify, I am giving this explanation to you. When we divide 72 by 12, we get 6 with 0 as the remainder. When we divide 72 by 18, we get 4 as the quotient and 0 as the remainder. When we divide 72 by 24, we get 3 as the answer with 0 as the remainder. 72 divided by 36, we get 2 as the quotient and 0 as the remainder. That means 72 is divisible by all the given 4 numbers. From the previous two sums, it is clear that there are two keywords to understand whether we have to find HCF or LCM. If you have to find HCF in the sum, the keyword will be that divides. If you read this word in a sum that divides, that means we have to find HCF. For LCM, the keyword is divided by. If it's in a sum, it is given divided by, then it is understood that we have to find LCM. Next sum, find the greatest number that will divide 93, 111 and 129, leaving remainder 3 in each case. So here the keywords are greatest number that will divide. So here that will divide is given, that means we have to find HCF. Second thing is leaving remainder 3 in each case. So this sum is slightly different from the previous one. In this sum, we have to remember that it is given leaving remainder 3 in each case. So we do not have to find the HCF of 93, 111 and 129. But we have to minus 3 from each number, and the result which we will get, we have to find HCF of those numbers. So here 93 minus 3 is 90. 111 minus 3 is 108. 129 minus 3 is 126. So here first statement we will write remainder in each case is 3. Then we will minus 3 from each number. Next step will be HCF of 90, 108 and 126. So HCF is 2 into 3 into 3 equals to 18. So here we got the HCF 18. This part is just to understand the sum, and this part you don't have to include while solving the sum. So when we divide 93 by 18, we get 5 as the quotient and 3 as the remainder. When we divide 111 by 18, we get 6 as the quotient and 3 as the remainder. When we divide 129 by 18, we get 7 as the quotient and 3 as the remainder. So it is asked that there should be 3 as the remainder in each case. So when we take 18 as the number, so we get 3 as the remainder. So here the final statement will be, therefore 18 is the greatest number that will divide 93, 111 and 129, leaving remainder 3 in each case. Next sum is find the least number which when divided by 9, 12, 16 and 30 leaves a remainder of 5 in each case. Least number divided by is given, that means we have to find LCM. Second thing is given that leaves a remainder of 5 in each case. In HCF, if remainder is given, we have to subtract that remainder from the given numbers and then we have to find HCF. Whereas in LCM, first we have to find the LCM and then we have to add that remainder in that LCM. So here we will find the LCM of 9, 12, 16 and 30 by common division method. Again, you can use any method to find HCF. So we get the factors 2, 2, 2, 2. That means 4 times 2, 2 times 3 and 1 times 5. So here we will multiply 2 into 2 into 2 into 2 into 3 into 3 into 5 is equals to 720. Remainder in each case is 5. This is given in the sum. So we have to add that 5 to the answer which we got, the LCM which we got. So 720 plus 5 is equals to 725. The last statement is that therefore 725 is the least number which when divided by 9, 12, 16 and 30 leaves a remainder of 5 in each case. One more type of sum. Find the greatest number which can divide 77, 127 and 176, leaving remainder 5, 7 and 8 respectively. So here number which divides is given. That means we have to find HCF. Now here remainder is given, but here single remainder is not given, but 3 remainders are given to us, 5, 7 and 8 respectively. That means we have to subtract 5 from the first number, 7 from the second number and 8 from the third number. So here we will subtract 5 from 77, so we get 72. When we subtract 7 from 127, we get 120. 176 minus 8 is 168. So we have to find HCF of 72, 120 and 168. I have already told you that in HCF, if remainder is given, first we have to subtract the remainder and then we have to find HCF. So we have subtracted and we got the numbers. Now we have to find HCF of those numbers. So we will find HCF of 72, 120 and 168. So the factors are 2, 2, 2 and 3. So 2 into 2 into 2 into 3 is equals to 24. So HCF is 24. Therefore, 24 is the greatest number which can divide 77, 127 and 176, leaving remainder 5, 7 and 8 respectively. One more type of sum which is slightly different from the previous sums we have done. Find the least number which when divided by 15, 25, 30 and 75 leaves a remainder of 5, 15, 20 and 65 respectively. The keywords are number divided by. So here we have to find LCM. LCM of 15, 25, 30 and 75. So when we will find the LCM, we get the factors 2, 3, 5, 5. So here LCM of 15, 25, 30, 75 is equals to 2 into 3 into 5 into 5 is equals to 150. Next important thing given in the sum is remainder. Remainder of 5, 15, 20 and 65 respectively. That means we have to subtract 5 from the first number, 15 from the second number, 20 from the third number and 65 from the fourth number. So 15 minus 5 is 10, 25 minus 15 is 10, 30 minus 20 is 10, 75 minus 65 is 10. That means here we are getting a common number that is 10. So this we have to subtract from the LCM which we got. The LCM is 150. So we will subtract 10 from it. So we will get 140. Here I am not writing the complete statement over here, as you might have understood how to write it. I'll just read it. From the sum, 140 is the least number which when divided by 15, 25, 30 and 75 leaves a remainder of 5, 15, 20 and 65 respectively. Next sum is slightly tricky and different from rest of the sums which we have done. Find the greatest 5-digit number which is exactly divisible by 12, 24 and 36. Here students make mistake by seeing the word greatest. They start finding the HCF. But here you have to pay attention that it is given exactly divisible by. So divisible by and divided by is one and the same thing. So here exactly divisible by is given. That means we have to find LCM of 12, 24 and 36. So here we will find the LCM of 12, 24 and 36. Again I am using a common division method and the factors which we get are 2, 2, 2, 3, 3. 3 times 2, 2 times 3. 2 into 2 into 2 into 3 into 3 equals to 72. So here the LCM we got is 72. Next important thing given in the sum is greatest 5-digit number. Greatest 5-digit number is 99,999 and we have to find the greatest 5-digit number which is exactly divisible by 12, 24 and 36. To find this, we will first divide 99,999 which is the greatest 5-digit number by the LCM which we got, that is 72. When we divide 99,999 by 72, we get 1,388 as the quotient and 63 as the remainder. Here remainder is very important for us. We will subtract this remainder from the greatest 5-digit number. 99,999 minus 63 is 99,936. So this is the number which is completely divisible by the numbers given to us, that is 12, 24 and 36. So the last statement we will write that 99,936 is the greatest 5-digit number which is exactly divisible by 12, 24 and 36. One more sum which is again slightly different from the previous sums. Find the smallest number which on being decreased by 7 is completely divisible by 18, 27, 32 and 36. So here the key word is divisible by. So here we have to find LCM of 18, 27, 32 and 36. So when we find the LCM, we get the factors 5 times 2 and 3 times 3. So we'll multiply 5 times 2 and 3 times 3. So we get the LCM as 864. Now this 864 is completely divisible by the given numbers, that is 18, 27, 32 and 36. Here we have to find the smallest number which is divisible by 18, 27, 32, 36, but the remainder should be 7. That means here on being decreased. On being decreased means when we will decrease that number by 7, then only it should be divisible by 18, 27, 32 and 36. But the LCM which we got here is completely divisible by these numbers. Decreased by 7 means we should get 7 as a remainder. So we will add 7 to the LCM which we got. So we will add 864 plus 7, that is equals to 871. So the answer will be 871 is the smallest number which on being decreased by 7 is completely divisible by 18, 27, 32 and 36. One more sum similar to the previous sum. Find the smallest number which on being added 9 to it is completely divisible by 10, 15 and 20. Again completely divisible by. So divisible by is given, that means we have to find LCM and the given numbers are 10, 15 and 20. So when we will find the LCM of 10, 15, 20, we get the factors 2 times 2, 1 times 3 and 1 times 5. So we will multiply 2 into 2 into 3 into 5 equals to 60. So LCM is 60. In the sum, it is given that we should get a number to which we add 9 and then only it will be completely divisible by all the given numbers. But here the LCM which we got, that is 60, is completely divisible by 10, 15 and 20. So what we have to do, we have to subtract 9 from it, so we will get 51. So when we will add 9 to this 51, then only we will get 60 and that will be divisible by all the given numbers, that is 10, 15 and 20. So the final statement will be 51 is the smallest number which on being added 9 to it is completely divisible by 10, 15 and 20. I have tried my best to cover all the different types of sums of HCF and LCM in this video. See you in the next video. Till then, goodbye.